Hello all. This video is going to talk about our first activity on machine learning. So we're going to use a library called Scikit-Learn. And there are other libraries that you'll want to install as well, just to make life easier. And I'll talk a little bit about what those are in just a moment. So we'll go through the code that I'm providing and talk about what it's doing in the hopes that this will help you to progress on working on this activity. All right, so I'm actually just looking at code here. I might try to make this just a little bigger if I can. Easier to read. Even if that cuts off a little bit on the right-hand side. Oh, that's maybe a little too big. There, how's that? That's a little better. The first thing we're going to look at is all of the different import statements that we're going to need for this activity. This will help you to see the different modules you're going to need to install for this activity, but also like how we would go about using them. I will note I'm going to go back and forth between the code in my editor and the activity text itself. And I'll just note that the activity text starts off with a list of libraries that you should install before you get started with the activity. All right, so let's look at what we're importing here. The first thing we're importing is the NumPy module. This is a great module. It stands for numerical Python. It provides a lot of highly efficient arrays, multi-dimensional arrays with fixed length data types. So we can have 8-bit, 16-bit, 32-bit integer arrays. We could have 32 or 64-bit floating point arrays. Well, you can have 64-bit integer arrays as well as other things. It has very highly optimized matrix and array operations. So it lets us do things with data that are very efficient and complex. We tend to use NumPy as a common representation for data that we might feed into a machine learning algorithm. We certainly use it for images, but it is also commonly used for things like CSV data or other things of that form. I'm also importing the matplotlib library. This is a visualization tool. It lets us draw charts and graphs of various sorts, and we are going to use the PLT part of it. This is a very large and complex module library. It tries to replicate all of the things you can do in MATLAB to display data, which is quite complex. So it's a very good tool to learn to use, although I usually just go and dig through its very extensive website to figure out what I want to do. All right, and the next step, we have all of the Scikit-Learn modules, submodules that we are working with. We're not importing everything. It's such a huge module. Overall, we tend to just import just the pieces that we need. I'll note that my editor is graying out some of these because most of the code down below has been commented out. So they would show up a little more brightly if I hadn't done that. The first thing we're going to use is a piece of the Scikit-Learn toolkit that contains example data sets. These are toy data sets or common benchmark data sets. We're going to use them because they're simple and easy to load, and it gets us through some of the data wrangling without too much trouble. But it also gives you a chance to see what it looks like when you read in data through something like Scikit-Learn directly. And then we'll compare that to what you see if you need to read in data that's stored in a file on your computer and not one of the standard data sets. We are also pulling just one piece out of the metrics sublibrary. The metrics module has lots of tools to help you analyze the performance of one of its machine learning models. And we are only going to use it to be able to display confusion matrix in a really nice looking format. So we're importing that by itself. We also are grabbing a couple of utilities from the model selection module. This first one is one of my very favorite of all time, train test split. It lets you give it your training data and your whole data set, and it will divide it up for you into training, validation, and testing with whatever properties you want those to have. It does automatic randomization. It's a very handy tool. I will sometimes import just this, even if I'm not otherwise using Scikit-Learn. We are also going to import a function that exists to perform cross-fold validation. So cross-val score computes a score based on running cross-fold validation. Other than that, the rest of what you see here are importing different models. Over the next week or two, couple of weeks, we are going to look at each of these models at least a little bit, understand exactly how they work. But for today, we want you to treat them as a black box. They're just different algorithms. They make machine learning models. We're just trying to try them out and see how they are similar and how they're different from each other in terms of how you work with them. And what you'll realize very quickly is that they are very, very similar in how you work with them, other than the parameters that you put in to tune each specific algorithm. So we're looking at a nearest neighbor approach. We're looking at a decision tree approach. We're looking at a support vector machine approach. I will just note that in my experience, linear SVC is probably the one you want to try with this activity and with your homework. I've had less luck with the general support vector classifier. We're also going to look at a simple neural network, not a deep learning model. Scikit-Learn has, until very recently, not done a lot with deep learning, but they do have a multi-layer perceptron, which is a shallow neural network. May only have an input layer, one hidden layer, and an output layer, but you can add more if you really want to. And it's the sort of the classic neural network that dates back to the late 1980s, early 1990s. We'll also look at two ensemble learning approaches, AdaBoost and Random Forest Classifier. And as I said, later on, we'll come back and look at exactly what all of those things mean. The last library we're importing is a very important one. It's called Pandas. This is one of the key tools that machine learning people who work in Python use because it is a library that knows how to read a wide variety of different data sources, and it can build a standard representation of them. So it can read JSON files or CSV files or Excel files or other kinds of data in various forms. And because it's a standardized representation that you get, it's easy to integrate with the actual machine learning algorithms themselves, and also to work with it, as you can come to very quickly to understand how it organizes the data. Next, we're going to look at the first section, which is really just playing around with the representation of data sets. So you can see here I'm using the datasets module, and I am loading three different data sets: the iris dataset, which is a classic, a small handwritten digit dataset, and a small wine dataset, which is also a classic. The iris dataset is a lovely little dataset. Someone took iris flowers and they had several different species or breeds or varieties, whatever you would call them, and they measured the length and width of the petals and the sepals of the flowers of the iris. And the goal is to be able to classify, just based on the dimensions of the petals and sepals, what variety of iris you have. The digit one is obviously attempting to identify individual digits, to take a handwritten digit and correlate that to which number it represents. And the wine category is similar to the iris one. We're looking at features of the wine, either through tasting or testing, and we're trying to identify the kind of wine grapes that were used to make it. All right, when you first load in a data set with whatever tool, it's very important that you actually start by figuring out what kind of data you have. So the very, very first thing I tried when I was starting to work with these data sets in Scikit-Learn was just I wanted to know what type of data we had here, and I just wanted to print it all out. So I'm actually going to run this in code as is, and we'll take a look at the first part of what it produces. I'll note that it's got a couple more steps and then I start commenting out the code. So I printed the type, I printed the whole data set. I'm showing you that there's a method called keys that all of these data sets have. We'll take a look at what that has. And then I also print out something called the description of the irises data set. And notice the notation here. I'm treating the irises data set as if it's a dictionary in Python. That's actually a thing. This particular data type, you can treat it like a dictionary, and that turns out to work very well for us. All right, so let's run this code. Takes a little moment to run just because we're loading a lot of things. I'm going to bring this up so you can see it. Scroll up to the top. Okay, I'm getting a little warning, and don't worry about that. I don't know why, but machine learning libraries like to print a lot of warnings. So this is the type of the data, the irises data that we read in from that print statement. And you can see that it's a scikit-learn type. It's called a bunch. We could go and look up the documentation page for that. I'm going to switch over just for a moment to Chrome and the activity, because I want to point out to you that in addition to showing you what you need to install and kind of talking through the data wrangling, as we get into actually looking at this code, I will provide you with a lot of links in the activity to documentation about each of these different things. It's a really good idea to start getting familiar with this documentation and how it tells you things and what it tells you. All right, let's switch back to the code. So we can see that it's a bunch object. When you look at what printed after that, you can see it's a little small, but there's a curly brace here, and then it says data, colon, and then array. That notation looks like a dictionary, a built-in Python data type. A dictionary has keys and it has values. This is an object that is more complex than that, but it is implementing, to put it in Java terms, it's implementing a dictionary interface. It's basically allowing us to treat it like a dictionary. So it has an element called data, and that data is an array. So what you're looking at here these are actually the petal and sepal lengths for each and every example in the data set. So there are a lot of those. We're going to scroll down past them all because we don't really need that. And then you can see here, this is the end of the data itself. We have a separate array, which is the targets. These are numbers that correspond to the three different categories, three different kinds of irises. You can see there are other things. Target names has got the names, Setosa, Versicolor, and Virginica of the irises, and the Descr, D-E-S-C-R, it has a formatted description. It's printing out kind of ugly here because we're printing it in the context of a dictionary notation, but it is there. And what you can see is right here is where I started printing. Actually, it might be right here, where I started printing out the description. And you can see that it prints out in a nice looking formatted way. It's fairly long, it has references and so forth. So all of that was embedded in the data set that I loaded. So that's what I got from calling this print statement and printing out the description component. I can pull the data out of that data type if I want, just by accessing it as if it's a dictionary. So irises subdata, that's the data. Irises subtarget, that's the target. I'm calling those X and Y. Remember that we tend to use X for the inputs to a model and Y for the targets that match the inputs. You can see there are lots of to-do statements here that you are going to use to expand this. You'll be experimenting with the wine data set, with the digits data set as well. All right, so most of what you'll do in this first section of the activity is just explore this. What is in each data set? How are they similar to each other? Are there any differences that you can notice? And what are the different keys for this dictionary-like object? And how can we use those to pull out the pieces that we might want? A lot of it is aimed at us. All we really need for the machine learning algorithm really is the data and the target. Everything else is for us humans. Okay, the next section here, which I am going to uncomment, at least a piece at a time, is again, we're talking about the data sets section of Scikit-Learn. So this is a model that Scikit-Learn has. It's larger. It's a real world scale data set. It's called COV type, and it's ecological data in essence. It has descriptions of patches of the world and the kind of tree cover that each patch has. So we're learning to associate the label for the type of tree cover with the data that we have about each patch. That's the goal. One of the things I note here is when you run this the very first time, it needs to download the data set. It's too big to just stream it to you, or possibly might be too big. So if that's the case, you'll notice that it's downloading, and there will actually be a file on your computer that stores the data. And you can actually, inside this call to fetch COV type, you can pass it the folder where you'd like it to save the data if you want. All right, I'm actually going to uncomment this print statement. I want to take a look at this. Yep. We're going to run this again. And then I will bring up the output. Okay, so here we can see the printing of the real world scale data set. And most of what's printing here is the information about that data set. All right, so you can see that it'll tell you there are 7 different classes. It has 581,000 instances, examples, and it has 54 different features, and there's some other data as well. When you look at this data type, data set, once you have loaded it in, the keys that we have are data and target, just like the other data sets: frame, target names, feature names, description. It's really the same. The nice thing about that is that whatever we do to one of these data sets, we can do something analogous to any of these others, and it will work just fine. Many, many times we do not have data in a data set that is hosted by Scikit-Learn. That's most of the time we want our own data. So we need to figure out how to go about reading in external data. And this is where Pandas comes to help us. Okay, I'm going to uncomment this whole section, then we'll go back up to the top and take a look at it. So this is reading in an external data set. This is a data set. This is a robot example. Sensor readings 24. So we have our idea is we have a little robot. It has 24 distance sensors, like sonar sensors or infrared sensors, that are spread around it. And we have collected data with a human driving this robot around the perimeter of a room. And what we would like is to train a model to predict, given the sensor readings, what the action should be. So should it go forward? Should it turn left? Should it turn right? Those kinds of things. So that's what the data set contains. It's in a CSV file. It's always good to take a look at that CSV file, but I can tell you from experience, the CSV file does not have a header row, so it doesn't have a heading at the top, and we need to read it in. So I am using the Pandas module, PD, and it has a function in it called read CSV. It's a really good idea to use something that's going to read the data for you. Pandas is more robust for our purposes than something like the built-in CSV module that Python has, although you could use that as well. But in this case, all we have to do is to provide read CSV with the name of the file, a path to it, and in this case, I'm going to tell it that there is no header row. Otherwise, it will assume that there is one. And it will then read in the data. So we have sensor data PD here. This is another representation, a different representation of the data. And we need to figure out what's going on with it. So I did a little digging when looking at the documentation for Pandas, which I provide you a link in the activity as well. I discovered there was a head method that will print the first few rows of the data for you, so you can just take a look at it. And then I also discovered that there was a very handy method called toNumPy, which basically converts the data from whatever format it's in inside the Pandas data frame to just being a NumPy array. So we get sensor NP. And I am going to all right, external dataset in CSV format. These lines right here, these are the result of calling that head method. So you can see that it printed out the data in a compact form, but it printed out, let's say, the first 5 rows for us to see. What I see here that you might not realize is looking at this data, column 0 through column 23 are all the same kind of values. They're all relatively small. They get a little bit big here in places, but these are all the sensor readings. There are 24 sensor readings. They are in columns 0 through 23. What you see in column 24, that's the action that the human took in response to being in that situation. So that's the target. All right, here I printed out a couple of other things. I printed out the type of the data, which is a NumPy ND array. That was after I converted it to a NumPy array. It has 5,456 rows, and there are 25 values per row. 24 sensor readings plus the action, which is our target. And they are being represented as 64-bit floating point numbers. All right. What else got printed out? Well, I defined the X and the Y, and I'm going to go back to look at this. Sensor X has the first, that should be 24, so maybe there's a bug. What I did is to separate out the target from the others. They were all in one NumPy array. We typically want them not to be. And I thought that was looked wrong, and I was right. This should be a 24. I'll try to fix that before you work on the activity. But if it says 23, fix it. It's supposed to be a 24. So we have our big NumPy array, and we took a look at what that looked like. It had 24, the first 24 columns are the input data, and the last column is the target. We want to split that last column off. So I'm using NumPy slicing here. The colon at this position says I want every row, all rows, and then I want columns 0 through, starting at 0 going up to but not including 24. That will get me all of the data. And then for the target, I want all rows but just the 24th column. So that gets me just the actual targets. And then I printed those out. And that was it. All of this has just been making sense of the data, figuring out what it looks like. But I want you to notice that where we've ended up is we have a NumPy array that holds the data that we're training the model on, and a separate NumPy array that holds the targets for that data. And that's typically what you want to do. If you get to that position, you're in good shape. And notice that every row in our array is a separate example, a separate instance or sample or example. We call them all of those things. So the rows represent the different examples, and then the columns have the different attributes for those examples. And typically the Y is just either a vector, whether it's a row vector or a column vector, doesn't really matter to us all that much. This probably, it might be a column vector, I'm not sure. All right, we've got our data. The next step in getting ready to train a model is doing a split of the data into at least training and validation. You can also do training, validation, and testing. I think I'll take a look and see what my code does here because I don't actually remember. So train, test, split is, as I said, a very helpful function. It randomizes the data for you, and then it will split it according to how you suggest. So I'm giving it the X data and the Y data, the inputs and the targets for the iris data set. I'm telling it that the training size should be 80% of the whole. So I want 80% for training and 20% for validation. The last thing you see over here at the end, I'm feeding in a random string of numbers to be a random seed. So if you remember how random number generators work, they often like read something from the system time and they feed that into the random number generator, and then they generate random numbers in sequence from that. If you set a seed for a random number generator, it will always generate exactly the same sequence of values. So why are we setting a seed here? Well, I said before, if I'm going to experiment with, say, a k-nearest neighbor and an ADA boost and a neural network and a decision tree on the iris data, and I want to be able to compare the results, they should be seeing the same training data and the same validation data. When I set that random seed, it's still random enough, but every time I run this line, I will get the same random split into training data and validation data. The same examples will be in the training data every time I run this. So if I come back 3 days from now, I'll still get the same split. It just ensures that we're actually doing a fair comparison of the different models that we're going to run. All right, train test split returns 4 different values. It returns the input training data and the input validation data, the targets for that training data, and the targets for the validation data. So it takes those 2 arrays we started with and it makes them into 4 for us. This is super helpful. All right, we're going to look at the next section, which is how you actually train a model. So we're going to use k-nearest neighbors. The k-nearest neighbors classifier takes in 1 tuning parameter. I think it has a default value. I'm going to pass in like 5 or 3 or something like that. The way k-nearest neighbor works is it sees each of our inputs as a vector in some sort of vector space, and it finds the nearest neighbors in that multidimensional space, the most similar neighbors, and it uses their classifications to determine what our new classification should be. When I say 5, I'm telling it find the 5 nearest neighbors. So it's called KNN, K nearest neighbor. 5 is K. If I put in 7, it would use 7 neighbors. If I put in 1, it would find the closest neighbor, and so forth. You can experiment with varying that. You will get slightly different results, and the best value varies depending on the data. So KNN here is a classifier object. Classifier objects all typically have a function called getParams, which will print out the various tunable parameters that they have, and they will all have a method called fit, which actually trains them. So I printed out the parameters here, and then I called fit, and after I run this, the k-nearest neighbor will contain the model that we need. All right, so I've run this. I don't know if anything much is going to print out. Well, it printed out the k-nearest neighbor parameters. So algorithm auto, leaf size 30, metric Minkowski. This is a dictionary, so it's the auto algorithm, the default algorithm. Leaf size of 30, I don't even know what that means. I'd have to look it up. It's using the Minkowski for the calculation of what is similar. And it has 5 neighbors and a couple of other things as well. You can modify any and all of these. When you call that function, you can pass in different values. You need to look at the documentation page to see what to do with all of these things. All right, we're going to pause here. So we've looked at a lot of data wrangling that you can do, and we also looked at actually training a model, so having it ready to feed into a model and have it actually trained. In the next segment, in the next video, we will look at how we evaluate the model once it has been trained. We'll also look at cross-fold validation, which is an alternate way of training the model, and just see how these different tools work. I will see you all very soon.